So next thing we're going to look at cofactors of a 3x3 matrix. This says the cofactor of an element of a matrix is found as follows. We would ignore the row or column containing the element and find the determinant of the remaining elements. So that is how every element in a matrix has a cofactor. Let us say starting with a 3x3 matrix. Every element in a 3x3 matrix, a square matrix, has a cofactor element, or there is a cofactor of every element in a 3x3 matrix. How do we go about finding this cofactor? We ignore the row or column containing the element and find the determinant of the remaining matrix. Now, give the cofactor a positive or negative sign depending on the position of the element in the matrix. For a 3x3 matrix, the pattern of signs is, so the sign of a element in a cofactor matrix depends on the position of the element in the matrix. For a 3x3 matrix, the pattern of the signs are, for the first row, positive, negative, positive. For the second row, negative, positive, negative. For the third row, positive, negative, positive. All right. So the next thing I'm going to do is I'm going to skip this section and go straight into showing you how this thing works. So in 35, example 35, we're going to find the matrix of cofactor of this matrix here. Now, the first thing I'm going to do is I'm going to find the cofactor for every element in the matrix. And I'm going to assign it the appropriate sign based on this pattern. The pattern of positive, negative, positive, negative, positive, negative, positive, negative, positive. All right, so let's go. First row. So this is the first element in the first row. Sorry. Second element in the first row. Third element in the first row. So let's find those. How do we find the cofactor element? First of all, the sign here is going to be positive. We are told that we should what? Ignore the elements in the row and column where we have this particular element, and then find the determinant of the remaining matrix, So if we ignore the first row and the first column, the remaining matrix would be this. 3, 2, 1, 4. So the determinant would be 3 4s 12 minus 2 1s 2. The cofactor element is 10. Second row. Again, we're going to ignore the second element in the first row, ignore the first row and the second column, minus, and find the determinant of the remaining matrix. This is -1, so this is minus. -1 times 4 is -4. -2 times 1 is 2. This is -6 inside the bracket, and negative times a negative is a +6. the third element in the first row. The sign of the cofactor matrix is positive. Ignore the last column and the top row. Find the determinant of the remaining matrix or the resulting matrix. And this would be minus 1 times 1 is minus 1, minus 3 times 1, which is 3. This is minus 4. Now, next move on to the second row. So we're going to ignore this is the first element in the second row. We're going to ignore the row and the column that that element is in and find the determinant of the remaining matrix. Minus 2 4 is 8, minus 1 times 1, 1. This is minus 7. Second element in the second row. So we're going to ignore the second row, second column. Find the determinant of the remaining matrix. This is 4 minus 1. This is 3. Second row, third element. So I'm going to ignore the second row and the last column. On the third column, second row, ignore all those elements. And find the determinant of 1, 2, 1, 1. This is minus 1, minus 2. This is minus 1, 1. Third row. The sign pattern is positive, negative, positive. So ignore the first row and ignore the last row and the first column. Find the determinant of the remaining matrix. This is 4 minus 3. This is 1. Second element in the last row. So ignoring the last row and the second column. Find the determinant of the matrix that results. So ignoring this and this. And we're finding the matrix of 1 minus 1, 1, 2. This is, the sign convention is negative. So this is 2 minus 1. Inside the bracket is 3. This is minus 3. And finally, the last cofactor element. Ignoring the bottom row and the right column. Find the determinant of the 2 by 2 matrix that remains. The sign convention is positive. So it's 1 times 3 is 3, minus 2 times 1, minus 1, which is minus 2. And this is 5. So my cofactor matrix would be, our matrix of cofactor, matrix of the cofactor elements would be 10, 6, minus 4, minus 7, 3, 1, and 1, minus 3, 5. All right, so example 36 says find the matrix of cofactors. So let's find the cofactor of every element. The first row, right? So those are the elements of the first row. The sign conventions for the cofactor elements, for the cofactor matrix, for the first row is positive, negative, positive. How do we find a cofactor element? We're finding the cofactor element the cofactor for the first element in the matrix, first element, first row. You're going to ignore the elements in the first column and ignore the elements in the first row and find the determinant of the matrix that remain. So the matrix that remain is 0, minus 1, 1, 4. So this is 0 minus 1, which is 1. The cofactor of the second element in the first row which would be this row, this element. Ignore the elements in the top row and the middle column and find the determinant of the remaining matrix. The sign convention is negative. So this is 4 minus 1. No, sorry. It's minus 3. So this is minus 7. The cofactor of the third element in the first row, you're going to ignore the top row and the last column, the right column, and find the determinant of whatever remain. 1 times 1 is 1, minus 0 times 3 is 0. This is 1. Second row, so we're at the second row now, first element. Ignore the elements in the second row and the first column. The sign convention is negative, positive, negative. So this is 2, 2, 1, 4. This is minus 2 4s, 8. Minus 2 1s, 2. This is minus 6. Second element in the second row. Ignore the elements in the middle row and the middle column. Find the determinant of the remaining elements, or the matrix formed by the remaining elements. This is minus 4, minus 6. This is minus 10. Then the third element in the middle row, so we're ignoring these and finding the determinant of the matrix formed by the remaining elements. The sign convention is negative. Minus 1, minus 6. This is minus 7. Negative times a negative is a positive. Let's move to the third row. The sign convention is positive, negative, positive. We're finding the determinant of 2, 0, 2, 1. So the determinant is 2 minus 0, which is 2. Second element in the bottom row, ignore here and here. It's the determinant of minus 1, 1, 2, minus 1. This is minus, and we have what? 1 minus 2, positive 1. Lastly, cofactor of this element, ignore the elements in the row and the column with the for that particular element, and find the determinant of the matrix formed by the remaining elements. And this is 0 minus 2 minus 2. So the matrix of cofactor would be 1 minus 7, 1, minus 6, minus 10, 7, and 2, 1, minus 2.